Hi, we're Team 9623B.
This is the 2016 CREATE VRC High School National Championship video.
And we're going to go ahead and start with introductions. My name is Nick. I'm in the 11th grade, and I am the driver for the team.
My name's Noah. I'm also in the 11th grade, and I'm the programmer.
My name is Anthony. I'm in 12th grade.
My name's Ed, and I'm also in the 11th grade, and we're the builders.
So this is our robot, Mr. Bucket, and it's primarily a high-go shooter.
And what a lot of people ask us whenever we go to competitions is, what was the most difficult building task? And for that, we usually just say that the most difficult building task was mounting the pneumatics piston in a vertical way without breaching the wall and still having it shoot, still having it go in a horizontal direction.
So the way we fixed that is the way we fixed that vertical movement to horizontal movement was quite a simple solution actually. We added a small hinge here, so whenever the piston fires upwards, it moves that hinge and moves the whole plate forward, ejecting the ball from the robot.
And truthfully, through that difficult task, it actually became the strength of our robot, because now we can have a ball sitting in the seat and still grab 3 more balls without having to worry about our ball ejecting.
The ejection mechanism also gives our ball an initial velocity, so when the ball enters the flywheels with an initial velocity, it doesn't take away as much energy from our wheels and as much energy away from the gear train.
Unfortunately, with every strength becomes a weakness, and our team's quick thinking fixed that very fast. These 2 walls, when the ball goes up the intake, as demonstrated, originally the ball will hit a certain spot on our shooter, and it would cause us a misfire. But now with these 2 individual walls here, they allow it to
Absorb shock and slows the ball down so it doesn't launch into the shooter. And while we're on the topic of our shooter, we can...
If we ever had to go back and change something on our robot, it would probably be to add a center pinion gear in between these 2 driven gears here. Adding that center pinion gear would remove this drivetrain play here, which would cause this delay here with the drivetrain play to be almost nothing. Our engineers from Cummins actually helped us with this design here, as it's similar to the design of camshafts and engines.
And even though the robot is the most important part of our robotics team, we still try to help in the community. And we've done a lot of different things. We've gotten grant money for many different high schools and middle schools in order for them to start their own robotics teams. We've also mentored and scrimmaged those same teams to prepare them for different robotics competitions. We've also had multiple demos for special education children, and as well as demos for career fairs throughout our state. And recently we just had another demo with the Chamber of Commerce of our county.
And back on the subject for our robots, we are going to talk about our shooter. And one of the issues that we have with our shooter is its inconsistency based on battery voltage. So what we did to remedy that is cruise control. And cruise control pretty much allows us to, well, it does allow us to change the speed of our motors at the push of a button. So pressing this button will up our motor speed by 5, and pressing this button will drop it by 5. And just so that while I'm driving I don't have to remember the actual numbers and what number we're at, how high we are, we have another button right here that I can press and it'll set it back to the default speed it was at originally.
if you get close enough, you can actually hear these cruise control work. It's actually pretty amazing. As it increases the power, you can hear it escalate, and when you decrease it, you can hear it as well.
So here in our notebook here, you can see these all these numbers here. What all these numbers show is our 30-second test that we ran in our drivetrain to actually calibrate all of our motors. So each motor was ran for 30 seconds, 6 times, and those values were all averaged together, and then those 4 averages were all averaged together to make a multiplier that we could multiply our base motors by, so they would all run the exact same speed. This is what we called our K value throughout this whole build.
So now we're going to go through our engineering notebook. It's a team photo with a supporter from SME.
These are all of our team members here. Some of these were moved to other teams as we expanded.
Yes, it's a early team photo with another team.
This here was just explaining the game.
It's just our timeline and our goals.
These were weighted objectives tables. These were actually very crucial in the design of our robot.
This was more designing our robot, making sure everything would be perfect. These were used in tandem with the weighted objective papers. This is actually right.
This is our first competition of the season, actually. We ended up winning this competition. This here is actually our code knob here, so we don't have to constantly re-upload code. These are some CAD drawings here. This one is of our wheel well.
It's another competition we attended. This is our previous seat for our pneumatic ejector.
These are some test fires we did with the 2-piston design, the old one, and the single piston design we've done now.
This is a lot of the work that we've done with the calibration values, as well as graphing our deceleration of our shooter. This is our cruise control code, and more testing that we've done with our motor calibration. More testing with the motor calibration. This is some designs that we use for different objects, and these are our CAD drawings that we've made.
And now we're gonna show you how this baby works.
Woo! Exciting part of it. All right, so
Part of it was all.
So that's our intake mechanism there, which pushes it against the wall. And here we're actually going to demonstrate our cruise control system. So I'm going to
roll up the ball tube, drop it in, fire it. I can lower the speed a little bit.
So he's actually able to get closer and lower the speed with the cruise control. And there you can actually see our pneumatic, our ejector working with our flywheel.
This is the really fun part of the competition. It really shows that our driver is one of the biggest parts of our team.
While our drivetrain might not be the fastest, it is the most maneuverable. We're capable of moving in all 8 directions, which makes up for our loss of speed.
Which helps us out a lot on picking up balls and getting into position to shoot fast.
Now, as we are playing the game, we realized that having a higher battery voltage causes the motors to be very sensitive. So we actually added a code where we're able to adjust, we're able to make very minute rotation adjustments.
Well, like I said, direction is very important for us. Our drive is pretty sick.
So this is our video for our 2016 Nationals competition, and we'd like to thank you for watching it.
And we want you guys to come and get us an interview out of our pit, and we'd be really grateful.
Yeah, we have so much more to explain and so much more to show. So,
Woohoo!
thank you
This
for
is
watching
just the
video.
beginning. Yeah, we're ready.